So Python has a number of methods that are available for lists. And so what's a method? You're going to see that sometimes things are functions where we have a name of a function and then between parentheses we pass in an argument. And then other things are methods. And so a method is kind of like a function. But with a method, you have an object, which is your variable name. So, for example, when we name a list, my names or my numbers or something like that, that will go here under object. Then you put a dot, and there's a number of functions that only work with objects of a certain type or variables of a certain type. So, if your variable is a list, you have certain methods that are available for just lists that you access with this dot operator. And then what you do is in parentheses, some methods will take arguments, which basically are just things that this method is going to use to modify this object. Some don't. If there aren't any, you still have to have the parentheses to use a method. It's just that you put open and close parentheses. So let's look at some common methods for lists. So I'm going to open up Visual Studio and let's make a program and we'll call it list methods demos. How about that? .py. And let's make a list. We'll just make it a simple 1, 2, 3, 4. And let's say we want to add to that list. Well, I think we already used this. We can use the append method. And then let's print the list to see what we got. And you can see we started off with a list that was 1, 2, 3. We appended 4, and it added that 4 to the list. Similarly, I could make a names is equal to and I could say names.append and just put in another name and then let's print those names and see what happens with that one. And we can see that we started off with ccldd in Earl and we added Rob. So that's an append method. And again, the object in this case is names. Because names is a list, we get access to the append method. And one of the nice things is that you'll notice that if I put dot, IDEs like Visual Studio Code will actually give you a list of methods that are available for you. If I said name, for example, if I said number is equal to 5 and I put number, you'll notice that there's no append in here because numbers, you can't append to a single number. If I have, on the other hand, if we took a look at list, give myself some more real estate here. If I look at list and I hit the dot, you can see it has the append even though it's a list of numbers. So as long as this thing is a list, the append method will be available. Similarly, if I had, my tuple is equal to 1, 2, 3. If we look at my tuple dot, you notice there's no append on tuples because it's not mutable. So that's one of the differences between a list and a tuple. Tuple is lighter weight, it takes less memory to manage, but it also doesn't have all the functionality of a list. So that's the append method. Another method which is useful is, let's see, I will save that, and I'm going to rename this. Let's make another program, and we'll call this count method demo. And so we have a list of words, and we can do this. And so what we're going to do is we're going to use this count method. And what this count method will do is it'll count up how many times 2 is in this list. So we're going to say there are and maybe I'll actually display that list. So what we'll do is we will say, oh, I need to rename this to be .py. That's why it's not recognizing this is Python. Okay, so now what we're doing is we're saying, hey, let's make this list of words. And then count up the number of the word 2, and then display to the user. And we can see there are 2 2s in to be or not to be. And that's done with this count method. So we use that count, that returned it counted up that there were 2 in those. If I were to count up or, it's going to, I really should change this here as well. I'll rerun it so it's not lying. And then there's just 1. So it only counted 1. So we can use that count method to count up elements. And we could do something like this, like say, well, we'll need a few more things in order before we could do more in that. But that kind of gives you an idea of what you can do. And this can be done with numbers as well. So if this was a list of numbers, you could count up the number of instances of a particular number. It just goes through and sees how many times this is equal to the elements in that list. And again, the way you use it is you take the name of your list, you put a dot, you specify that you want to use the count method, and then you put in here what you want to count up. Another method is the extend method. So I'm going to make another, call it extend demo.py. And so let's say that we have a list like this, 1, 2, 3, and b is equal to 4, 5, 6. And we will say a dot extend, and it's asking for an iterable. Basically, an iterable is a sequence, so we'll grab b, and then we will print a and see what happened. And we can see it took, this is printing a. So a originally was 1, 2, 3, b was 4, 5, 6. When you say extend, it actually just concatenates the two together. It puts it, and this can be done this way as well. You could also say a is equal to a plus b. And it'll do the same thing. One thing to note though is notice that we have to say add a plus b and then put it back into a. Otherwise a would remain the same. So we actually have to assign this back in. There's actually a shortcut to this. We can say plus equals b, and this will also concatenate. We'll see that it does the same thing. And all of these do the same type of function. I'll put this back in here just to show that it's the same. And since we're really talking about the method, you can do either, all three of these will do the same thing. And then let's close some of these up. Let's make another one. And the other one is the index method. We've already played around with that a little bit. We'll review that here. And so, oh, actually, no, did we use the index method? Let's give it a try. So let's say we have nights is equal to So the index method will actually look for the first instance of this value inside of this list. And so let's see, we need to store that somewhere in order to do something with it. So we'll say index of who is equal to that, so that we know what that is. And then we'll say print who is located at index in so we're going to get this is index method is going to look in this list, find where the index of who is, and then display it. So it's at index 4. So we's at 0, r's at 1, these at 2, nights is at 3, and who is at 4. So it found the index. So this can be used as a lookup function. Let's see what happens if we don't if we don't if we provided something that isn't in the list. So we'll look up herring in the list. And you'll notice that we get a value error. It says herring is not in the list. So if it is there, it will give us the number. If it isn't there, it gives us an error. This also brings up a possibility of using index for a lookup. So let's make a let's say that we have two lists. Names is equal to Cecil, DD, and Earl. And then we have numbers is equal to those three numbers. And what we want to do is this. We want to create a list of names and phone numbers. They're really, we'll say, extensions. And then what we want to do is show list of names, ask user to type in name, and then find number and display number. So typical, workflow for working with a phone book. Well, what we could do is, well, how do we display the names? We use print. And it looks like this. Okay, there's our names. And then we want to ask the user for a name to type. So we'll just say name equals input because it's a string. We can just leave it like that. And say, please enter name. And so what we'll do is we show a list of names, please enter name, and if someone puts in Earl, okay, that's working. And then we need to find the number. Well, how do we find the number? Well, these are parallel lists. Cecil is 1, 2, 3, 4, DD is 2, 3, 4, 5, Earl is 3, 4, 5, 6. If we find the index of the name in names, then we can get the number in the, use that index to find the number in the other lists. So we're going to say index of name is equal to names dot, we're going to use the index function. And what are we going to look for? Well, the name that the user gave us. So we're going to take this name that the user gave us, pass it to the index function in this list, and store that in this variable called name, index of name. Now, the number is going to equal numbers. And how do we get the number that corresponds to that index? Well, we use our square braces, and this number that corresponds to the same index as the name that was given is basically just done this way. So we use the indexing method to find name in the list. Then we take that number that we got and index it using the square braces out of numbers. I know that we use the word index a lot here, but we just realize, this, whenever we use the square brace and put a number in there, we get the corresponding value. So if this was, for example, 2, 0, 1, 2, that would give us Earl. But we're not going to hard code that. We're going to use what we got from the user. So we take the name from the user, use the index function to get the number of the index where that name that they gave us was in names, store that here, take that number, use it with the square braces to find the corresponding number, And then down here we will print name, or I'm going to use double quote so I can get an apostrophe S. Number is, and then number. So now what's going to happen is we'll just say whatever the person's name is, put the apostrophe S for a possessive verb. This is just a string. And then display the number. So let's see what happens. So if I put Earl's number is 3456. Yep, that's correct. Let's run it again. And let's try Cecil. 1234. And yes, Cecil's phone number is 1234. So this allows us to take and really create two parallel lists. And this is an important concept of doing lookups. In fact, you could, if you had multiple values in here, you could actually make multiple, you could do addresses. Or maybe emails is equal to Cecil at aserver.net, comma d at aserver.net, and we could do Earl at a server. These are just strings, .net. So I have 3 more strings. And I could then say that email is equal to emails, which is the list, dot index. And oh wait, I don't need index. I already got the index. It's the same index. So I'm just going to use that index of the name, just like I did here, to now pull out another piece of information. And now I can say, and email is email. So now I'm able to I now have both the number and the email, and I can get both of those out of here. So now if I run this, and the email is dd@aserver.net. So really this is kind of a table if you think about it. And if I look up a value in one, I can use the index to find the elements in the other. It's kind of sideways. You can kind of turn your head in the sideways and kind of looks like a table. But each one of these is separate columns in a table. So that's how to use the indexing method. So we already did a delete demo, and with the delete, what we did is we provide an index number, and we use this delete function. But there's also a remove method. The remove method is a little bit different. So let's create a new one, and we'll call it remove method demo.py. And what we're going to do is create a list and remove an item and then display the list. And so let's see if I can. So let's say that we have this numbers one, and then we're going to remove an item. So we're going to say numbers dot remove, and what do we put in here? Actually, I think I want to use names because I think it'll be a little bit. Do I have that in the demo? Nope. So I'm going to put. Let's do it this way. Let's do what they did in the book. So I'll say words is equal to we use this. So we have a list of words, and then we remove B, and then we will print words. So this is a little different than the delete function, because with the delete function, you provided an index number and it removes that. With the remove method, what it does is it looks for the first instance of this and then it will remove it. So you notice it removed the first B, it didn't remove the second one. So it doesn't remove all instances of B, just the very first one. Now let's say that we put something in that wasn't there. What will happen? It gives us a value error. X not in list means basically couldn't find this in the list. So if it's not there, it'll give us an error. But if it is there, then it will actually do the removal. So if I did or, for example, you would see that it would remove the or now. And we could turn this into maybe a more interactive program by saying ask user for word to remove. Well, they need to know what words are there, so otherwise I'll get an error. So we'll say display words, which will be just like this. And we'll say word to remove is equal to input. Please enter word to remove. And now rather than using the literal string we have here, we're going to put in the variable that we got from the user, and then we'll display it. So now if we run this, let's see, I'll type in not, and then there it removed the word not. So that's different than the delete method. Now, remember in the delete demo, we provided an index number. We had to convert whatever, we asked the user for a number, and then it removed the element at that number. The remove searches in the list for whatever you want to remove and finds it and removes it. So slight difference between remove and delete. Another demo, the list method we can use is the reverse method. And so we could we'll create a list, reverse it, and display it. So we'll make a simple list. We'll say numbers is equal to 1, 2, 3. Then what we'll do is say numbers dot reverse. And notice that reverse doesn't take any arguments, but we still have to provide the parentheses. Otherwise, Python won't know what that is. So it needs the parentheses to know that we're calling this function. Watch what happens if I don't do that. Well, and then let me display the list just so that we can see what happens. So if I just put reverse, it doesn't actually do anything. To call this function, Python needs the parentheses to say, oh, you want me to actually execute this method. So we see, even though there's no arguments in this method, we still need to provide the parentheses, and we just do that by putting open and close parentheses. And now we can see that reverse did its job, took the list and put it in reverse order. So that's the reverse method. Another useful method is the sort method. So we're going to create a list. Sort it, and then display it. So we'll say numbers is equal to, and we'll just put in some random things here. And then we will sort it. So we say numbers dot sort. Again, it doesn't take any arguments. And then we will print numbers to see what we got. Yes, and there we have it. 1, 2, 4, 6, 7, 9. So it took this list and put it in order. We can actually use an optional parameter here. We can say reverse equals true. And if we put this in here and run it, we can see we get the list in reverse order. So, you can also do it this way and you'll get it in order, but reverse equals false is always the default, so we don't really need to put in reverse equals false if we want it to be reversed. So those are some common and useful methods that are available for the list class. Thank you very much.